Welcome to my kcse revision channel. Teacher James Marita, Kirigol Boys High School. Kindly subscribe my channel. Click the notification bell such that you get notified once I upload a new video. Today we are looking at a kcse revision mathematics, and our topic today is trigonometry 3. So we have a question on kcse 2015. Let us look at kcse 2015. In kcse 2015, so we have kcse 2015, and solve the question. So we have and our equation is 4 sine, it is 4 sine squared theta plus 4 in this case cos theta, and this one is equivalent to 5 for theta ranging between 0 degrees and 360 degrees. Give the answer in degrees. Give the answer in degrees. So from this 4 squared, 4 sine squared theta plus 4 cos theta is equivalent to 5. You need to recall these identities, that sine squared theta plus cos squared theta, this one is equivalent to 1. Therefore, we can express the sine squared theta in terms of cos squared theta. So from here, if we express the sine squared theta in terms of cos squared theta, you get that the sine squared theta is equivalent to, if we express in that form, it will be cos squared theta minus 1. So, or you can have this as, this is 1, then we have cos squared theta. That's if you express that one that. Therefore, our 4 sine squared theta plus 4 cos squared theta will be equivalent to, we have this one as 4, then this is 1 minus cos squared theta. We have expressed sine squared theta in terms of sine squared in terms of 1 minus cos squared theta. Then plus 4, we have cos theta, and this one is equivalent to 5. We open the bracket here, so we have 4 times 1, we have, this is 4 minus 4 times cos squared theta, we have this as 4 cos squared theta, then plus 4 cos theta, and therefore this one is equivalent to 5. We can correct the right terms together in that case. We have 4 and then we have 5. We can transfer this 4 to the other side, such that we remain here with 4 minus 4 cos squared theta. So we are transferring this one into that, and then we subtract. So we remain here with minus 4 cos squared theta, then plus 4, we have cos theta, which will be equivalent to, now we can have this as 5 minus 4, and that one is giving us 1. So what can we have now? To form a quadratic equation from here, you remain with 4 cos squared theta plus 4 cos theta and then therefore we are removing this one from this side to this one, such that we have a quadratic equation. So if we subtract 1, and on this side we remain that one with 0. The 4 squared theta, the ax squared, in the form of ax squared plus px plus c is equals to 0, the coefficient of x squared must be positive. So this one must be positive. It means that this part here, negative 4 squared cos squared theta must be positive. So we divide by a negative, or we divide here by negative 1. This one we divide by negative 1. This one we divide by negative 1. And of course here we divide by negative 1. Such that we have this as 4, negative and a negative. We have 4 squared cos squared theta, then plus minus now 4. We have this as a cos theta, then plus 1, and therefore that one will be equivalent to 0. To find the value of theta here, there are various methods that can be formulas that can be used. You can use the completing square method, you can use the quadratic formula, or you can use the sum and the product. So in this case, if we use the sum and the product, we have 4 squared, 4 cos squared theta, then minus, this is 4 cos theta with plus 1, and this one is equivalent to 0. So what is the product here? It is 4 times 1. So our product is equivalent to 4, and the sum in this case is equals to negative 4. And the factors we can have there, the factors we have as negative 2 and 2. So we have the factors here, which is negative 2, and in this case, negative 2 and a negative 2. So negative 2 times negative 2 is equals to positive 4. And negative 2, negative and a negative, negative 2 times negative 2 is equals to positive 4. Negative 2 plus negative 2, the answer is equals to negative 4. So, and in this case now, this one will replace, we can have this as a 2 cos. This is negative 2 cos theta. Then we have plus, minus, we subtract, this is 2 cos theta. So instead of having negative 4 cos theta, we can now have the sum of 2 cos theta minus 2 cos theta. So we have, this is 4 cos squared theta minus 2 cos theta minus 2 cos theta, then plus 1, and therefore that one will be equivalent to 0. Then from here, we have 4 cos squared theta. We can group this one into 2 like that. So from here we have, it is 2, which is common here. It is 2 cos theta in that case. So we have, this is a cos theta, such that cos theta times cos theta is equals to cos squared theta minus, here we have negative 2 minus 2 cos theta. So, and we have factored out these 2 cos theta, so we subtract 1 like that. And then we have, this is 2. We have, this one is 2. 2 times 2 such that we have as 4. Then we subtract on this side. 1 is common here. Then we have 2 cos theta minus 1 in that case is equals to 0. So we have 2 cos theta. This is 2 cos theta. Then minus 1 into bracket. This and this one are the same, so we pick 1. So we have, this is 2 cos theta minus 1 is equals to 0. From here you can conclude that 2 cos theta minus 1, 2 cos theta minus 1 is equals to 0. So from here we picked 2 cos theta minus 1 is equals to 0. So we have this is 2, then we have cos theta, which is equals to 1. Once we take 1 on this side, which is a negative, it will be changed to be a positive. Dividing by 2 in both sides, you will have that cos theta is equals to p, cos theta is equals to p half. If cos theta is equals to p half, the value of theta will equivalent to, you find now the cos inverse of a half, which is of course giving us 60 degrees. But now this is not the solution for theta. At this point now you need to recall the use of a unit circle. If you recall the use of a unit circle, we have our unit circle from trigonometric 2. So we have our unit circle like that. So after having this unit circle, we need now to record where is the cosine thing a positive. So here we have this is all of the trigonometric ratios are positive. Here only the side which is positive, the tangent is positive here, and the cosine is positive there. In the first quadrant we have only theta. In the second we have this is 180 minus theta. On the third quadrant we have this is 180 in this case plus theta, and then the fourth quadrant we have 360 in this case minus theta. Now where is our cos being a positive? Because we have this is positive a half, so we can find it in the first quadrant. All the trigonometry here are positive. So in the first case we have it is positive here. So we have at this point we have 60 degrees. Because we are talking of theta, we have here 60 degrees. And then we have the cosine is also positive in the fourth quadrant. So we also get it here. But at this point here, we have it is 360 minus theta. And in case our theta is equals to P, 60. So at this point we can have 360 minus 60 because our theta is equivalent to 60 and this one is giving us 300. Therefore, the value of theta from this unit circle, you conclude that theta is equals to P, 60 degrees and 300 degrees, such that our range it ranges between 0 degrees and 360 degrees. Get kcse made familiar and do a lot of practice. You will be getting a lot of these questions from past papers, mock papers, and the kcse papers, and then you will do yourself well in the kcse examination. Don't forget to subscribe, click the notification bell such that you get notified once I upload a new video. Thank you for watching.